Let's look at question number 10, regular expression matching. Regular expression is a very common concept in the R language. R language provides the regular expression library to handle it. Now, in this question, we will write our self regular expression matching function. The input is a string and a pattern. If this string can match this pattern, we will return true, otherwise return false. This one, they give a little different definition about how to match wildcard in the pattern. So dot means can match any letter, and star combined with the preceding element can match 0 or unlimited repeat one letter. So we can use this one as an example to explain what happened. So B will match the B, and A star will match AA because A can unlimited repeat, and C star will match empty because it said match 0. So C star can be the empty string. So we can use that example to explain what happened for this one. So in this case, first we concerned B star is an empty string. So after we concerned the B star is empty string, we can continue match AA BB with AB star because we remove this B star. For this one, we continue to remove B star. So we compare AA BB with A. So this way it's died because A cannot match the B. Then we consider B star can match B, 1B. So AA B will continue match with this one. So this one will remove the B star. This way is dead. Okay, for this one, B star can match the B, so we can continue compare A and A B star. Then B star can be empty, so we go to the AA and A, so this way is died. And B also cannot, here is no B, so this one is dead too. So look like we can use the recursive to find all situation and to run it. Let us start to write the algorithm. So if we want to use the recursive, the original function is not supported. So we have to define our self recursive function. So it's a match original string pattern, and we want from the last letter backward to the beginning. So will be the length, last pointed to the last letter, and then pattern's last one. So we can define the same return format. So it's private Berlin underscore is match string pattern string last one and pattern last one. So if we point to the out of boundary is before 0 index or less than 0 and less than 0, it means we both is reach the beginning of string and pattern. So in this way we will return true because we already finished. And then we defined Berlin to the false, and if still available, we can do it, right? Otherwise, we will return false because we cannot get any letter from the pattern. The reason is not to check as last, because if we still have, if the string already point to here, this is the first letter, the as last already go to the -1, -1, but if pattern is a C star, so C star can be nothing, so we still can match. So we will handle the as last later. Now it still is valid, and then we get the char from the pattern last, and if this char character is a wildcard, here we do some assume. We assume all the pattern give us is valid pattern. So if you get the wildcard, we assume they must have a character before it, before star. This one will be the p char at p last -1. And remember, we will first to check if we remove this b star, we consider b star will be empty. What happened? So if this one and this one, we remove the something star, so S still is S list and P list will be -2. If this one return true, we need to return true. This means we find this pattern and the string is matched. Otherwise, we'll continue. So by this one, we need to compare. We need to compare this one with the last char from the. So we need to compare 8 if before star, if this one is daughter, it means we can match any letter, or char at s laster is equal to before star. However, if s laster is less than 0, is out of this string, we will get the error here. So if we need to compare this one, we need to have a precondition is s laster should bigger than 0, big equal 0. So this is a precondition. If this happens, then we can write the return value equal to this one. And the last, as last we minus 1 means we backward 1 position, and this is a go backward 2 position, because actually it's no, it's here. So we find a 1 match here, right? So we just go back 1 position, but the pattern keeps same. Okay. If this one is not star, and it's not star, we need to check the letter from the pattern is matched to the letter from the string. So first we need to have this condition. So if actually we can continue right here, right? And okay, so p chart is a dot, they can match everything, or s chart at s master equal to p chart. In this one, we will do this. So because this one is not star, so we backward 1 position for string. We also need backward 1 position in pattern. Okay, we finished the code, I think. So let us use this one to check it. So in the beginning, S is a AAB, and pattern is a C star, A star B. So we come here, and this pointer to the B, and this pointer to the B from the string. So they come here and come here and do recursive. Now B last is point to the this star, and the S last point to this A. We come here, and first we remove A star to compare C star with the AA. It doesn't match, so we continue use the A star to try to match this A. This happen. So we use this A star match this A. It's work. And then we remove this one, compare C star with 0 index minus, so S last is minus 1. Come here, and we go here, and both is less than 0, return true. So let us run the code. What's happened? So it's match S is 1. Okay, so this is REV, not RE, so it's REV. So run again. Okay, and then we submit the code to the. Okay, cool. This run very faster. However, let us consider some situation. So here, we continue analyze this code. So when here is stopped, we go back to here, right? And we think this how this way is cannot pass. So from this one, we continue to do it. So before we use this bx, we remove this bx compare. So right now we use this bx. So we will do this a b. This b will use this one to match. So the pattern is a b star b star, right? And let us do before we remove this bx. So it's a b. Try to match a b star. Here we find something interesting. This one and this one are exactly same thing. And we already know if you go to here, either way is failed. So if we can remember last time we meet this situation, and then we can stop here immediately. We not need to continue to calculate this one. So this is called dynamic programming. So dynamic programming is you use some place to remember some result. So next time when you reach the same situation, you do not need a calculator again. So we can add this class. We will use some Boolean array to see, do we meet this situation before or not? So we call this the flags. And we need to initialize this flag before recursive. So it's Boolean. Here is S line. Let us do this one first. We can modify this later. Here. So by this one, we can know all the situation. We remember all situation we reach here. We know it happened before or not. So dot, okay, here normally we use p and s. So p dot lines, we initialize them 4 to 0 and I2 less than the s and flags I1, I2 to the none. And then here, we do not need to go into this one. We can directly compare. But we may have the -1 as the index. So if we come here, we do if flags p last and s last is not equal to now, it means before we already reach it, and this one is false. We return false directly. But remember, p last and s last maybe is the -1. So we can increase this matrix to handle this situation. So when we do the initialize, we do this too. And then we can use +1 to help us find the correct location, so to avoid the negative index problem. And then here we can set the flag to this one. Then we can try again and submit it. I think it's slow than previous solution. Is LeetCode server is unstable. This should be faster than the first solution because they can avoid a lot of calculation we already did before. Yeah, I think this is a LeetCode server's problem. Thank you for watching this video.